Hello everyone. In this video, we are going to discuss about the topic complement of a set from the chapter Sets, chapter 1, class 11, Max. You see, we have already discussed about the other operations of sets like intersection of sets, union of sets, etc. in our previous videos, which will be available in the playlist. So you see, let us talk about this operation of sets, which is the complement of a set. You see, this is the simple, this one, no, just like a dash one, no. This is actually the symbol to represent the complement of a set. That is, if we consider a set A, then its complement will be represented like this. Okay, so this is A complement. Now, let us consider a universal set U, and let A be the subset of U. We have already discussed about subsets now. That is, all the elements in A will belong to this universal set U. Then only we can say that A is a subset of U. Okay, now you see the complement of A, that is represented like this, the complement of A. It is a set of all elements of U which are not elements of A. Okay, see, complement of a set, it is represented like this, and it is defined as complement of a set A is, it is the set of all elements of U, that is a universal set, which are not elements of the subset A. See, for example, in set builder form, we can write its definition as A complement equal to set of all X such that X belongs to U and X does not belong to A. See, we can write A complement as U minus A. That is the difference between the universal set and the set A that actually gives you the A complement, that is complement of A. Let us consider one example. Let U be the set of these elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then let set A be set of these elements, that is 1, 3, 5, 7, 9. You see 1, 3, 5, 7, 9, they are actually the elements of U. So we can say that A is a subset of U. Okay, so here if you want to write A complement, what about A complement? A complement is actually U minus A. That is, we want to write the elements in the set of A complement such that the element should be present in U, but it should not be present in A. That is, we want to write the difference between U and A here. So you see, we just want to subtract, we just want to remove this 1, then 3, then 5, then 7, then 9. So we have rest these elements now, that is 2, 4, 6, 8, 10. So this is actually A complement. Now, let U be the universal set consists of all prime numbers, and let A be the subset of U. Okay, A is a subset of U, and A consists of prime numbers that are not divisors of 42. Okay, let U be the universal set consists of all prime numbers, and let A be the subset of U which consists of all those prime numbers that are not divisors of 42. Okay, that is, in set builder form we can write A is the set of all X such that X belongs to U and X is not a divisor of 42. Okay, so here you see U, it is the universal set consists of all prime numbers. So U will contain the numbers 2, 3, 5, 7, 11, 13, 17, 19, etc. Okay, so here you see this 2, it belongs to U. It is an element of U. But 2, it is not it is a divisor of 42. Right, 2 belongs to U and it is a divisor of 42. So you see 2 does not belong to A. Okay, because the elements in A, they are not the divisors of 42. Okay, 2 is a divisor of 42, so 2 does not belong to A. Alright, similarly, if you consider this element 3, see 3 belongs to the universal set U. Okay, and 3, it is also a divisor of 42. So 3 does not belong to A. Okay, because the elements in A, they are not the divisors of 42. Now if you consider this element 7, 7 belongs to the universal set U. It is also a divisor of 42. So 7 does not belong to A. So you see 2, 3, 7, they are the prime numbers which are divisors of 42. So they do not belong to A. If you consider any other element in U other than 2, 3, 7, for example 11, 13, 17, 19, etc., they are actually not divisors of 42. So all other elements other than 2, 3, 7, all other elements, they actually belong to this set A. Okay, now if you consider set of these three prime numbers, that is 2, 3, 7. Okay, you see this set is actually called as the complement of A with respect to U. Alright, because A complement will be the set of the elements which are the divisors of 42. So A complement is set of 2, 3, 7. That is, we can write A complement is the set of all x such that x belongs to U, the universal set U, and x does not belong to A. That is, A complement is. Now, let us consider the universal set as set of these elements from 1 to 10. And let A be the set of these elements, that is 1, 3, 5, 7, 9. Then what about A complement? A complement will be U minus A. That is, you want to write the elements which belong to U but not to A. Right, that is, you want to subtract, you want to remove these elements in A 1, 3, 5, 7, 9 from U. So when you remove this 1, 3, 5, 7, 9 from U, you will get the elements as 2, 4, 6, 8, 10. These are the elements of A complement. So A complement will be this set. Now what about A complement all complement? A complement is U minus A. So A complement all complement will be U minus A complement. Alright, so this will be equal to what? You see, A complement has these elements. So U minus A complement means you want to remove these elements from U. Okay, that is, you should not write 2, 4, 6, 8, 9. So rest you have 1, 3, 5, 7, 9 here, no? So you can write 1, 3, 5, 7, 9 here. That is A complement all complement. Now you see 1, 3, 5, 7, 9. This set is actually what? A. This is set A. That is, we can write A complement all complement is equal to A. This is an important result. That is, we can write A complement all complement. This is the set of all x such that x belongs to U and x does not belong to A complement. And here you see A is a subset of U and A complement, it is also a subset of U. Now, let us see another important relation, that is A union B all complement is equal to A complement intersection B complement. Let us just check that. Let U be one set of 1, 2, 3, 4, 5, 6. Let A be set of 2, 3. And let B be the set of these elements 3, 4, 5. Here you see A is a subset of U. B is also a subset of U. Now what about A complement? See, A complement is actually U minus A. That is, in the set of A complement, you have to write the elements of U which do not belong to A. In A you have 2, 3. So when you write A complement, you should not write this 2 and 3. The rest of the elements could be written here. So you see, rest we have 1, 4, 5, 6. So A complement will have these elements in it, 1, 4, 5, 6. Okay, now what about B complement? B complement is actually U minus B. So in B you have 3, 4, 5. So you have to write the elements of U which do not belong to B here when you write B complement. So except 3, 4, 5, that is 3, 4, 5, rest you have 1, 2, 6 here. So you have to write that 1, 2, 6 here. Okay, now what about A complement intersection B complement? You see, when you consider the intersection of A complement and B complement, you have the set of A complement and B complement here, and when you take the intersection, you have to write the common elements present in both. So you see, 1 is common in both A complement and B complement. Then 6 is common in both A complement and B complement. No other elements are common in both. So when you write A complement intersection B complement, this set will have these common elements, that is 1, 6. Okay, so you see A complement intersection B complement is set of 1, 6. Now, what about if you find out A union B? See, when you write A union B, union of two sets, you have to write all the elements, no? Okay, you have to write all the elements present in both A and B, but no need to repeat the elements. Okay, so here you see when you write A union B, you have 2, 3 here, so it is written. Now in B you have 3, 4, 5. So 3 is already written, no need to write it again. So 4, 5. So this is A union B. Okay, now what about A union B complement? A union B complement, no, that is when you write A union B complement, you want to subtract A union B from the universal set. See, in the universal set, you have these elements. In A union B, you have 2, 3, 4, 5. So, 2, 3, 4, 5 should not be written here. The rest of the elements are 1 and 6. So, you can write 1, 6 here. This is A union B all complement. Okay, so when you compare these two, you can write A union B all complement. You see both are the same now. A union B all complement is set of 1, 6. A complement intersection B complement is also set of these elements 1, 6. So both the sets are the same. So you can write A union B all complement is equal to A complement intersection B complement. This is another important result. Okay, so if A and B are any two subsets of universal set U, then A union B all complement will be equal to A complement intersection B complement. Similarly, if you find out A intersection B all complement, that will be equal to A complement union B complement. So you see A union B all complement equal to A complement intersection B complement. That is the complement of the union of two sets, that is equal to the intersection of their complements. Similarly, A intersection B all complement equal to A complement union B complement. That is the complement of intersection of the two sets, that is actually equal to the union of their complements. Okay, and you see these two are called De Morgan's laws. Now, you see the complement of a set A, that is universal set U minus A. This A complement can be represented by a Venn diagram. You see this rectangle one that actually represents the universal set. And you see A is a subset of U, that is why it is here. Now, when you talk about A complement, it is U minus A. So, except A, all other portions should be shaded. So, except A, all other portions will be there in A complement. That is the shaded portion of the shaded portion actually represents A complement. The shaded portion actually represents A complement. Now, let us see some properties of complement sets. The first one is complement laws. That is, A union A complement will be the universal set U, and A intersection A complement will be phi, which is the null set or empty set. For example, Let us take the universal set U be the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These elements are there in U. And let A be the set of these elements 1, 2, 3, 4. So here, what about A complement? A complement is U minus A. That is, when you write A complement, you have to write the elements in U, but they should not belong to A. So you have to subtract this 1, 2, 3, 4 from U. So 1, 2, 3, 4. You should not write these elements here. So rest you have 5, 6, 7, 8, 9, 10. These are the elements in A complement. Now, what about A union A complement? This will be equal to, when you write the union of two sets, you have to write all the elements in A and A complement, but no need to repeat the elements. So A has 1, 2, 3, 4, A complement has these elements. So when you take A union A complement, you have to write all the elements in A and A complement. That is 1, 2, 3, 4 in A, then 5, 6, 7, 8, 9, 10 in A complement. So A union A complement is this. Now you see, this is actually the universal set now. So A union A complement, that is actually equal to, universal set U. A union A complement, this is actually equal to the universal set U. Now, what about A intersection A complement? A has these elements 1, 2, 3, 4. A complement has these elements 5, 6, 7, 8, 9, 10. So when you take intersection of two sets, you have to write the common elements present in both the sets. You see, no common elements are present in A and A complement. So this will be an empty set, that is a null set. So A intersection A complement will be equal to 5, which is an empty set. Now the next one is De Morgan's law, which we have already discussed, that is A union B all complement equals A complement intersection B complement, and A intersection B all complement equals A complement union B complement. Another one is law of double complementation, which we have already discussed, that is A complement all complement equals A. Now the another one is laws of empty set and universal set, that is phi complement, phi is the empty set, U is the universal set. So phi complement equals U and U complement equals phi. For example, let U be the set of 1, 2, 3, 4, 5. Phi is an empty set. So here when you write phi complement, this is actually equal to U minus phi. That is, you have to write the elements in phi. So you have to write the elements in U which do not belong to phi. Okay, so you see phi is an empty set. So the elements in U will be written here 1, 2, 3, 4, 5. Okay, which is actually the universal set U. So phi complement is U. Similarly, when you write U complement, this is actually U minus U. Okay, when you subtract all these elements from this, there won't be any elements. So this will be a null set phi. Okay. So in this video, we have discussed about the complement of a set from the chapter 1 Sets Class 11 Maths. We have discussed about all other theory portions from this chapter which will be available in the playlist. Thank you.